afternoon and welcome to Graphing Trigonometric Functions. Today we're going to see how this trigonometric function in its final form can be graphed over here on this Cartesian coordinate plane. Here's an example of a graph. We have all these variables filled in here, and how would it look on a graph? People ask, where do you start? Well, you know where I start? I start with the D value. Then I jump to the A value, and I'll explain all that. Then we do the C value, and then finally the B value. DACB. So, what is D? D is a phase shift up or down. It is found at the end of the equation normally. It is what I refer to as misdotted, because at 1, we're going to put a dotted line. Now don't say Miss Dash because we might have infringements rights. So Miss Dottie is at 1. That's where the middle of our road is going to be. A is the amplitude, and that tells us how far up we're going to go and how far down we're going to go. So that creates what I like to refer to as the road. So this would be 4, and this would be -2, while that's at 1. It's 3 units up, 3 units down. That is our road that our sine graph will be flowing onto. Where does the graph start? Well, technically it started way over there, but a one sine graph will be starting at pi/4. This is a phase shift. We had a phase shift vertically up here. Now we have our phase shift horizontally. It is opposite this. Therefore, the sine graph will be pushed to the right pi/4 units, which means it will start, because it's a sine graph, it will start right here in the middle. It will then, because this is positive, it will then flow up, down, and finish one time. How far will it go? Well, that's the part that most students have trouble with. Most students look at the B value and say 2. But we all know that's not true. We know that B times P is always 2 pi for this problem, where P is the period of the function and B is simply the number that goes right there. Okay, so if B is 2 times P is 2 pi, therefore P is pi. What does that mean? It means that's how long one ride on this sinusoidal roller coaster is going to be. That means when I start here and I go up and down and come back up, that distance needs to be pi units. That doesn't mean that's where I'm going to end. It's where I finish from here. So if I know this is pi/4, I have to find pi/4 plus pi units, which is right there. That is pi plus pi/4. That is where I will end. And if I'm smart, I'm going to put another point in the middle, because that's where it's going to come through. So we're finally ready to graph our sinusoidal function. Now we know it goes forever, and we know it goes forever, but there is this graph of one sinusoidal function. Thank you very much.